this video, let's discuss yet another fun and interesting question from Introduction to Trigonometry concept. So guys, the question is, if sin A equals 3 by 4, calculate cos A and tan A. Alright guys, so first let's write what is given in the question and what we have to find. It's given sin A equals 3 by 4 and we have to find cos A and tan A. Right guys? Let's take a look at the solution next. The next step is to form a diagram based on what is given. So simply we have a triangle. I've named it as ABC only because the question demands angle A, right? So I've marked angle A over here. Now it's given sin A equals 3 by 4. Right guys? From the diagram, what is sin A? Sin A is nothing but opposite side divided by hypotenuse, which is BC by AC equals again 3 by 4. Right guys? Okay, now, is it right to assume BC is equal to 3 and AC equal to 4 units just by saying that you can compare the numerators and the denominators of the equation? Is it right to say that? No guys. For an example, imagine BC was equal to 9 units and AC is equal to 12 units. Yeah guys? What would sin A be? Sin A is again BC by AC. In our example, it would be 9 by 12. And of course, we will simplify it and we will get 3 by 4. So guys, in that example, BC and AC were actually of lengths 9 and 12 units. But sin A ended up becoming 3 by 4. So guys, we don't know the values of BC and AC. Yeah? And hence we can't assume that they are of 3 and 4 lengths. But when it comes to trigonometric diagrams, we can write 3 and 4 along the sides BC and AC. Why is this so? It's simply because we are dealing with ratios. Right guys? If we look at this triangle and if we consider sin A, when we look from angle A's perspective, sin A should look like 3 by 4. So it's okay to write 3 and 4 beside the triangle. However, it is not right to assume that actual lengths are 3 and 4. We've learned this reason in our previous classes as the values of the trigonometric ratios do not vary with the length of the sides of the triangle if the angle of the triangle remains the same. Alright guys? Okay, so let's continue with our question. Now we've assumed that BC and AC are in 3:4 ratio. Okay? Now we have some idea about these two sides of the triangle. Right guys? In order to find the third side, what should we do? We should apply the Pythagoras theorem in triangle ABC. This will give us hypotenuse square, which is AC square, equals the sum of the squares of the other two sides of the triangle. Right guys? Now since AB is our unknown side, let's rearrange this equation, which will give us AB square equals AC square minus BC square. Okay guys? Now we know the values of AC and BC. It's a ratio and we can take here AC and BC as 4 and 3. Alright guys? Okay. So AB square is equal to 4 square minus 3 square. AB square equals 16 minus 9. Alright guys? On subtracting, we'll get AB square equals 7. How do we find AB from this? We have to take square root on both the sides, which will give us plus or minus root 7. And the negative sign is neglected. Why is that guys? It's simply because AB is the length of the side of a triangle. And the length can never be a negative quantity. Right guys? So let's insert this root 7 in our diagram. Okay. So now we have the complete triangle. Yeah, we can easily find out what is cos A and tan A. Right guys? Cos A is equal to root 7 by 4 and tan A will be equal to 3 by root 7. Alright guys? So I hope you understood this question. Thank you.